So let's now look at the Laplace transform of an integral. Now we've seen this before when we looked at the Laplace transform of the unit step function and we derived it graphically. But now we're going to go and we'll go through the analytic derivation. So let's say we had a function f of t, and when we did the Laplace transform it gave the function f of s. So we're interested what happens to the integral from 0 to t of f of t by dt when we Laplace transform it, what we're going to get here. So we'll just work through the Laplace transform. So it's the Laplace transform of the function. Well, our function is just this function, 0, integral from 0 to t of f of t by dt. So we'll go through the Laplace transform. So it's going to be the integral from 0 to infinity of e to minus st by dt times our function. Well, that's our function there. The integral from 0 to t of f of t by dt. Now, we're going to go and use the integration by parts in order to solve this. So we've seen in the previous video, if we were to integrate u dv, then it's equal to u times v minus the integral of v du. So if we make our choices for our u and our dv, so let u equal the integral from 0 to t of our function f of t by dt, that means that du is going to equal just the f of t. So we differentiate this, we differentiate that side, and the integral will disappear, we'll just be left with the f of t. If we let dv equal e to minus st, then whenever we integrate this side, we'll get a value of v, so integrate this side, we'll get minus 1 upon s e to the minus st. So now we've got our four elements here, we can stick them into this equation up here. So we're going to have our u times v, so our u is the integral from 0 to t of f of t by dt, and our v is going to equal e to the minus st upon s, there's a minus there as well, all of that minus the integral of v du. Okay, so we're saying our v is minus 1 upon s e to the minus st, and our du is going to be our function f of t. So we can see if we leave this side alone, so we'll just leave that exactly as, and we'll look at this section here. So in this section here, the two minuses cancel out, we can take the 1 upon s out, so we'll just have 1 upon s, the integral from 0 to infinity e to the minus st f of t by dt. So again, sticking with this here, you can see all this is 1 upon s times, and this here is simply the Laplace transform of the function f of t, which is f of s. So this section here is simply the 1 upon s times f of s. So in this section here, if we were to put in the value for infinity in for t here, then we'd have e to minus st. Well, that would just tend towards 0 as t tend towards infinity, and this term would dominate, so we just get 0 for that. And if we put a value of 0 in, well, the integral from 0 to t of f of 0 again will just be a value of 0. So this whole term here just gives us a value of 0. And we've seen that this term here is going to give us our 1 upon s f of s. So finally we can say that the integral from 0 to t of f of t by dt, when we Laplace transform it, is going to give us 1 upon s times our function f of s. So that's all there is for this video. I'll get you on the next video. Goodbye.